All right, does anyone know what this is? Exactly, I heard it. This is meth. This is Blue Sky, actually, from Breaking Bad. So, Walter White from Breaking Bad has a PhD in organic chem. This is actually part of the plot line. I'm not making this up. And he did synthesis in seasons 1 and 2 to figure out how to make the meth that everyone was crazy about in the show. See? Yeah, Walter White, Sky Blue, or Blue Sky. All right. And this is just for your own FYI, just the synthesis of meth. This is the methylamine they used that was really hard to get access to. And this is all the stuff they started with, the P2P. They went with an imine intermediate, and then they got the good stuff. And if you're interested, I got this from a website. You know, feel free to learn about how to make meth on there. All right. Okay, so synthesis, there's good and bad news with this. The good news is, or I should start with the bad news. The bad news is it's going to be on every exam from now through the final exam for Orgo 2 at the end of your spring semester. The good news is it's probably the easiest exam question. It's a free 10 points. And my job is to show you how to get all 10 of those points very easily. How this problem works is they'll give you some product or substance and ask you to propose a synthesis of it using reactants that have less than some number of carbons, say 4. Okay. So the keys to synthesis. These problems can sometimes appear very intimidating, maybe not for this first midterm because it's going to be very basic and simple, but later on they'll add lots of substituents, double, triple bonds, and a lot of other stuff. But the key for this exam is to get it down to having an alcohol somewhere. And why would I say that? The only reaction you currently know that will help reduce your carbon count, say breaking a 6-carbon structure into a 4 and a 2-carbon structure, involves the use of an alcohol group. One of the most important things for this is to draw your arrows in the proper way. Since this is a retrosynthesis, remember, you're given a product. So the arrow tip must be on the side of the product because you're creating reactants. The grad TAs always say, kids, draw the arrow the wrong way and you'll lose points for that, so don't lose some simple points there. Okay, so the way I organize this, I'm going to go through the 6 reactions we all know and love. So the first one is very simple. It's if your problem has a double bonded carbon in it somewhere. So you would consider using this reaction here because it will take your double bonds and you would write both of those carbons involved in the double bonds, one with a hydrogen and one with a bromine. Now, it doesn't matter which carbon gets the bromine and which gets the hydrogen. This is how these synthesis problems work. They're very simple. You're just going to write the arrow and the reactants involved in it. Okay. Okay. So I'm going to run a quick clicker on this. It's on the last reaction you just saw. Okay, so I think it's open. Now the question is, which of the following reactants will generate this product up here using that reaction I just showed you, which involves the double bond and the bromine and hydrogen? Sorry? It's not an option, right? Should I start again? Which arrows? Okay, there we go. Sorry about that technical difficulty. I've never written a clicker question before. Okay, I'll give you guys like another 10 or 15 seconds. This is a really simple problem to go with. Okay, I'm going to stop it in right now. Okay, the correct answer was indeed E. Woo. All right. Okay, so I made this question just to reiterate the fact that it doesn't matter where you add the bromine and where you add the hydrogen. In this case, I added the bromine up here and the H there from this double bond. So that would be carbons 2 and 3. In this case, I just reversed it. Doesn't matter which order you go in, whatever makes you happy. And later on, when I review some of the harder reactions, we'll discuss a strategic place to maybe put the bromine. Okay, so the next reaction is PCC. This is by far one of the most important reactions you'll learn in all of organic chem. You'll use this non-stop, and why is it so handy? It'll take you from your carbonyl that you're given and make it directly into an alcohol. And as I said before, the goal of your synthesis is to get an alcohol group somewhere in your carbon compound. Because once you get that, you can start cutting and reducing your carbon count, which is what the problems are all about. I made this little example here to show you that the carbon with the carbonyl is where the alcohol will attach. I noticed some students were putting the alcohol maybe terminal or somewhere else. It doesn't switch, and that would be wrong if you put it in the wrong carbon. It'll go clearly from that right there. Am I going too fast? Are you guys getting all this? There are TAs, floating around. Feel free to ask them to clarify, and these slides will be posted. Okay, so the third reaction. The third reaction is another very, very important one. Why? It involves the alcohol, the OH group. Now, the perk of this one is you're going to have, the problem on the exam will have a bromine already on there for you, right there. And this reaction will take it straight to the alcohol. So you just draw your arrow, put the HBr, and go with it. Okay. Oh, go back, sorry. Okay, I'm going to go forward. Okay. So guys, quiet down. The next reaction, guys, come on, quiet down. The next reaction involves if you have a lithium carbon compound. Now this is a really rare structure because most of you would just never put a lithium on a carbon compound. But this reaction is very important because when you do some of the other reactions, you'll end up creating a reactant with a carbon and a lithium in it. And what if that compound has, say, 5 carbons and you need less than 4? This is the reaction that you would go to, because it'll take that lithium off and make it a bromine. And from there, you could work with maybe the last reaction and turn that bromine back into an alcohol and then get ready to cut. I drew that down here just to show that we have a structure with 6 carbons. So clearly, this might not be an acceptable exam question, but you get to this intermediate. What you would do is you just rewrite it and put the bromine in the spot and then consider using some other reactions that you know of. Okay. Now, this is probably one of a rather complicated reaction to learn, but a lot of students eventually figure it out. I mean, even I did. I got confused with this making the slides last night. So this is if your product is just a pure saturated hydrocarbon, meaning you only have single bonds and nothing else. This is probably the hardest situation to analyze, but this is how you do it. You'd use the reaction H2PDC. HH is just short for H2. So this reaction will throw a double bond into whatever molecule you have at anywhere you want. You can make it terminal, you can make it the first and second, you can make it the third and fourth, anywhere you want, and you're good to go with that. Now, it's important that you put both H2 and PDC, and you have the arrows in the correct orientation again. So this is really if they just give you a bunch of carbons and hydrogens and nothing else to work with. And something else you could consider doing is you'd take this and get a double bond And now with your double bond, I showed you another reaction early on that can make that into the H and the Br. So you see all these reactions, they're all going towards one place. And a few reactions ago, we showed how the bromine can be turned into an alcohol, which is what we're trying to get at. You guys all good so far? All right, awesome. Okay, reaction number 6. This is the reaction that everyone always has trouble with. I know in the workshops and at office hours, several TAs have been confronted with lots of students who have a lot of confusion with this. So I took a lot of time in showing how this reaction works and exactly how to do it so you'll never mess it up. So this reaction shows that if you have an alcohol, which is what I said the goal, you can break that into 2 carbon compounds, a carbon lithium and a carbon carbonyl compound. And then under acidic conditions, you would be able to garner a larger carbon chain product. So this is the reaction that we will use that will help reduce your carbon numbers on your carbon compounds. The reactants for this reaction are very, very important. One will always be a carbon compound with a lithium, and the other will always be a carbon compound containing a carbonyl. And I clearly indicated that because it's really important because you're only given 2 pieces to break it up into, so it should be really simple to deal with. And again, at this stage of the reaction, now we're getting ready to cut and actually reduce and work towards synthesizing the product of our choice. And just on a side note, it's very important that you clearly indicate that we're under acidic conditions. As in, if you only write your carbonyl structure and you don't put acidic conditions, you will lose points, because that's a very important part of this reaction. And in the later chapters, you'll see why acids and bases environments can be very beneficial or hindering towards reactions. So it's really important we put that in there. All right, we good? All right. Okay, so I basically came up with this molecule down here. So everyone just copy it down because we're going to be working with this one for the next couple of slides to actually learn how we cut. The key to this, reaction is to label your carbons. You need to count them and label them appropriately. And if you do it the way that I'm going to display, you'll never get it wrong, I promise. All right, so does everyone have this down? This is a little bit of an unrealistic molecule. They wouldn't have to use synthesize this because it's already 4 carbons or less. But I just picked it for the heck of it. So let's go with it. Okay. So this is just a final pathway, and I'm going to show you how we get it back to this. How do we go from here to this carbonyl and this structure with the lithium? I'm going to show you the answer so we can work back step by step and figure out how does every piece fit into this reaction. Once you get this reaction down, you'll basically have mastered synthesis for your your second midterm. Okay, so step 1, as I said before, you should label and count your carbons. Now the way I was taught this by a TA last year was your carbon with the alcohol, so this carbon right here, you will label that as carbon number 1. So that's what I dubbed the anchored carbon because it's anchored to your alcohol. And now any adjacent carbons directly adjacent, like I made a point to clarify that, you should letter A and B. I was told to use letters because it really makes the product and the reaction much easier to keep track of. So now we clearly see that we have 2 bonds. We have bonds 1A, which would be from this carbon to this terminal methyl, and then from this, again, carbon number 1 to B. So what I'm trying to build up is that we could cut any of these 2 bonds, bond 1A or bond 1B. There's no right or wrong way to do this. There are many pathways that will garner the correct answer. And we'll discuss some better pathways and some not so better pathways just to save you time and steps. Okay, so now that we've labeled 1A, 1B our bonds, you could even have 1C if you had a third group. You can pick which bond you want to cut. So for argument's sake, I just picked bond 1A. We'll work through that one together, and I also put up the answer to 1B. You guys should definitely do that just to check yourself. So I would suggest you just put a visual cut right there. This shows you that you're severing this entire compound at this area. This will really visually help you stepwise to see what you're going to have create this 4-carbon structure with the alcohol. So this reaction is basically broken up into two components, the carbonyl portion and the carbon-lithium portion. So the first portion I suggest you work on is the carbon-alcohol portion, which will be the carbonyl portion. Now, I know it just sounds pretty confusing, but just pay attention to what I say. So you see that we have this alcohol here. It's attached to carbon 1, and we have a total of 1, 2, 3 carbons beyond this half of the bond, which is why I said you should really cut it, because you could really see how many carbons we're working with. So this alcohol portion will turn into our carbonyl. How that exactly happens is as follows. You'll redraw this exact thing, so 1, 2, and 3. Now I have put carbon 1, I labeled it again for you. We have 1, 2, 3 carbons, good. We didn't add or subtract any carbons. And now instead of writing OH, all you have to put is a double bonded O, and you're good. And you'll notice that technically this carbon wouldn't be fully satisfying its octet by doing that. So just for the argument's sake, I showed you the hydrogen. You'll never have to show hydrogens on these problems because it's implicit, it's known. This is just so you guys see that I'm not changing any hybridizations or anything of that sort. Everything is clearly preserved. And you'll put this structure over your arrowhead. And again, underneath your arrowhead must go acid, so H3O+. I clarified that point there. It's really important too. In the heat of the moment, it's really simple to just forget something so little, but it is very, very important. So again, just to reiterate, all we did was we counted this portion in this like blue box. We got all the carbons and the carbonyl. So now let's move on to the next portion, which is the other part, the carbon-lithium part. So after you've created the carbonyl, you're done with this entire half. This thing is done. It's over the arrow. You're done. You can just ignore it and be happy that you know that you got it right so far. Now, what about this portion of the bonds? In this particular case, I made it so there's only a terminal methyl. You can easily have branched structures here and things of that sort. But what you do is very simple. You're going to take this part beyond this half of the bond, the non-alcohol portion, as I indicated in the box, and you're going to redraw it over here. And preserving the carbon count, you'll just add a lithium. Now this is one of the trickier steps because a lot of students will often add or drop a carbon here. Because let's say you had 3 carbons here with some number of bonds, they'll redraw that and just attach a lithium. But what students forget to and will realize the hard way is that you will create a substance with less carbons than you started with. So it's really important that you count your carbons here. I know that at all of the reviews I attended last year, a lot of the great TAs always told us one of the best things you could ever do in Orgo is to count your carbons. You don't want to lose any simple points because you forgot something. Like they even gave it to you right here. So in this case, I took my methyl group, so CH3. I brought it over here. It's still labeled as A just so you guys can keep up. And it's attached to lithium. And at this point, you're done. It's that simple. If you follow this scheme that I showed you with all the letters and the numbers, and actually drawing out where the bonds cut and what goes where, you'll be fine. Are you guys good so far? I know this is probably a confusing portion. Anything you want me to repeat? Yeah? I'm sorry? Oh, the H3O+? That's part of the reaction. It's just there. You don't have to wonder where it came from. You can just draw it there and you'll be good. But you have to keep it there. This was drawn in your synthetic library of reactions from your workshop. Any other questions? Yeah, Eddie. Yes. Although in this particular case, I don't know if you could, but that is possible if you're starting, we'll give it to you. Yeah, we'll go through that pathway next, actually. Very good. Are there any other questions on this? Any point I could clarify? All right. Okay. So now, this is, I think, what another student just asked us. Oh, like this? Okay. So another pathway you can use is if you had chosen to cut what I called bond 1B. Come on, guys, quiet down. So if you choose to cut bond 1B, which was this bond from carbon 1, which holds our alcohol, instead of A, which I dubbed to be our methyl, and B over here, this is what you'd get. Now how this happens is the same way. We would take our portion with the alcohol, which would involve these two carbons at this point because we're cutting here. I'd rewrite it, and now I just add a carbonyl where that alcohol was. And then I'd take the remaining portion, so these two carbons from there and there. I'd redraw them to make sure I have two carbons, which I do. It's a great way to double check yourself that you count and have the right number of carbons. And then you just add your lithium structure in. So this is what this would be if you had an aldehyde reacting with your carbon lithium structure. Question? Yes? I don't think it really matters which way. As long as you draw it with the right number of bonds, you don't double or triple bond anything, you have it in your carbon bond formation, you'll be good. I just chose to draw it this way. I prefer to draw my Marvin sketch, I guess answers upwards starting. I always do it that way. All right, so are we good with this pathway, 1B? All right, awesome. If you guys have any other questions, contact me or the other Ts and we'll go through it until you guys get this. Okay, so now these are just some patterns. I looked through a bunch of your old exams and found that the professors usually just repeat some ways and some problems. Come on, guys. Settle down. So in this case, the professor gave you a structure that has the carbon-carbon double bond in it. What you would do in that case is you would address your 6 synthetic reactions, and this is just some steps to help you notice what to do. Step 1, you would use this reaction because it's the only reaction I think that you know that will take a double bonded structure and take the double bond away. And if you're given the double bond, that's exactly what your goal is. If you guys remember, this was the slide. It had the H and the bromine and the clicker question. Your next step, since you have a bromine, would be to use HBr because that'll take your bromine a step back and make it an alcohol. And the goal of all of this is to get back to the alcohol so we can cut. And then that's how you would cut down there. See, these problems aren't really that bad. They're only a few steps long. In this case, maybe 3. Another common trend I noticed was when the professors would give you a carbonyl. And this is an even easier step and way to do this set of problems because you'll take your carbonyl using PCC and go straight to the alcohol. There's nothing else to deal with. And then you create your alcohol and then get ready to cut. These problems are, again, like maybe 3-4 steps long. They're not going to be crazy hard for this midterm, but they're still very tricky and something to definitely focus on because you want to get all the points on this. Okay, so I'm going to run another clicker question. This one deals with the alcohol reaction and how we actually cut. Okay, so guys, please click in. I'm going to give you 30 seconds. Sorry, you guys weren't supposed to do that. It's out of control. Okay. Well, still, in case anyone managed to miss that, keep going. Got it. Okay. Okay, so the answer is C. You guys all clearly mastered this. A lot of students, as I thought, would pick B accidentally, despite the fact that I put the answer up there. You should notice that there's one carbon. You can cut this bond, and this bond. There are 3 possible bonds to cut, and I'll show you where they are on the next slide. And this is the answer. I colored them in. The first bond is your black bonds, then you have your blue bonds, and your red bonds. I just want to get to a couple of more points because my time is running short. Okay, these are just some problems I put up. I want you guys to try these on your own tonight, and I'll post the responses somewhere. I'll probably just howl it or put it up somewhere, but I'll make sure to get you these answers. There are many pathways. I want you to explore all of them. Okay, so these are just some closing remarks I have for you. Count your carbons. Don't mess up. It's a very simple thing to do. It happens to all of us. Another, oh, sorry guys, the slides will be posted. I just want to get to these points first. They're really, really important. Don't waste your index card space by putting these reactions on there because they will be given to you on your exam cover. I also suggest, just if it's your first time doing synthesis, that you actually put an example on your index card just for you to refer to in case you forget or you freeze. All right. The goal of these is to get to the alcohol. I just want to reiterate that point. It's really important. Get to your alcohol, then cut